Dark matter is the name scientists gave to a large amount of mass that has to exist somewhere in the universe even though nobody can see it. We know it is there because of how it pulls on things. Galaxies and huge clusters of galaxies pull on the objects around them far more strongly than the stuff we can actually see should allow. So the name is not really describing something we found. It is describing something we can feel through gravity but cannot look at directly. The reason this idea exists at all comes down to a simple mismatch. When astronomers add up everything in a galaxy that gives off light or blocks it, meaning the stars, the glowing gas, and the dust, they get a total amount of mass. Then they measure how that galaxy behaves, and the behavior does not match the total. There is not enough visible mass to produce the gravity the galaxy clearly has. Something unseen is supplying the rest of the pull. That mismatch solves a real problem. Galaxies spin. If a galaxy only had the mass we can see, its fast-moving outer stars should have been thrown off into empty space a long time ago, the way a load flies off a truck bed on a sharp turn if nothing holds it down. They were not thrown off. They are still there, still circling. Dark matter is the placeholder for whatever mass is holding them in place. Let me show you exactly how this works, one idea at a time. Start with gravity itself. Gravity is mass pulling on mass. The more mass an object has, the harder it pulls on everything near it. This matters because every single thing we are about to figure out is measured through gravity, not through light. We are weighing things we can never put on a scale. Think about a crane lifting a steel beam. The operator can feel how heavy that beam is by how the crane strains and how it swings, not by looking at it. If the operator misreads that weight, the crane tips over. More mass means a stronger pull, and that pull is something you can measure. The next idea builds directly on that. You can figure out how much mass is present by watching how fast things move around it. Fast orbits need strong gravity, and strong gravity needs a lot of mass. This matters because it is the only way we can weigh objects in space. Nobody is flying out to a galaxy with a scale. We watch the motion instead and work backward to the mass. That crane operator judging weight by feel is doing the same kind of reasoning. Read the motion wrong and you get the weight wrong and the job goes badly. Orbital speed tells you how much mass is there. Now, the part that lets us see the gap. Visible matter is only the portion of the universe that gives off light or blocks it. Stars, glowing gas clouds, dust. That is the only matter a telescope can point at directly. This matters because a telescope is a light collecting instrument, and if something does not touch light in any way, the telescope has nothing to collect. An electrician runs into the same limit. A wire behind drywall might be alive, but you cannot see the current. You confirm it with a voltage tester that reacts to the effect. Treat the wire as dead just because you see nothing and you get shocked. If something does not interact with light, a telescope cannot see it. Here is where the trouble shows up. Galaxies spin and their outer stars move far too fast. Most of the visible mass in a galaxy sits packed in the center, so the stars way out at the edge should orbit slowly. Instead, those outer stars orbit almost as fast as the ones near the middle. This matters because the speed does not fit the visible mass. The stars at the rim are moving as if something massive is out there with them, spread all the way through the galaxy. The outer edge of a galaxy moves faster than its visible mass should ever allow. That speed mismatch means mass is missing. The only way those outer stars can move that fast without escaping is if far more mass is present than we can see, spread throughout the whole galaxy, and not just the bright center. This matters because it turns a strange observation into a clear conclusion. The gravity is real. You can measure it in the speeds, but the matter causing that gravity does not show up in any image. Think about an accountant closing out a company's books. The totals do not add up, and that gap is not nothing. It means a transaction happened that was never recorded. Ignore the gap and the audit fails. The gravity is there, but the matter causing it is not visible. So we give that missing mass a name. Dark matter is mass that has gravity, but does not interact with light. It does not shine. It does not glow. It does not block light or cast a shadow. It reveals itself only by pulling on things. This matters because it explains why we are so sure something is there while being unable to point a camera at it. We are detecting a thing purely by its effect, the same way that an electrician trusts the tester over his own eyes. Dark matter is felt through gravity and is never seen directly. Now, a fair objection. Maybe it is just ordinary stuff we missed. Ordinary explanations have actually been ruled out. Scientists checked the faint stars too dim to notice, the cold gas that does not glow, the dust and the black holes. This matters because those are the obvious answers, and good science tests the obvious answer first before reaching for a strange one. A mechanic hearing a knock in an engine checks the cheap common causes before blaming the engine block. Skip that process and you replace an expensive part that was never the problem. When astronomers count every ordinary source, the shortfall is still there. The missing mass is not just dim, ordinary matter we overlooked. This is the important part because the case does not rest on one measurement. Mass bends light, and that bending confirms the extra mass in a completely separate way. When light from a distant object passes near something heavy, its path gets curved. So astronomers measure how much a galaxy cluster bends the light of objects sitting behind it. This matters because it is a second, independent way to weigh the same cluster, and it does not depend on orbital speeds at all. A surveyor checking a property boundary does the same thing when he confirms the line with both a tape measure and GPS. When both methods agree, the number holds up. Rely on only one, and a boundary dispute can cost you in court. The light bending points to far more mass than the visible matter can account for, and the amount matches what the spinning already told us. Light bending gives a separate measurement of the same missing mass. Now, clear up two things dark matter is not, because these get mixed up constantly. Dark matter is not dark energy. Dark matter pulls things together with gravity. Dark energy does the opposite. It pushes the universe to expand faster and drives things apart. This matters because the two words sound like a pair and get swapped in everyday conversation, but they do opposite jobs. If you swap them, you have the behavior of the universe exactly backward. Dark matter pulls in. Dark energy pushes out. Dark matter is also not antimatter. Antimatter is real, it interacts with light, and it destroys normal matter on contact in a burst of energy. Dark matter does none of that. This matters because the names sound related and lead people to assume they behave alike. Antimatter is loud and detectable and reactive. Dark matter is quiet and barely interacts with anything at all. Antimatter is detectable and reactive, while dark matter is neither. Now, the honest limit of what we know. We do not yet know what dark matter is actually made of. It is almost certainly not ordinary atoms. The leading guess is some kind of unknown particle that has mass but barely interacts with anything else, and no experiment has caught one yet. This matters because a lot of coverage makes it sound solved, and it is not. The evidence that dark matter exists is strong. The identity of the ingredient is still open. Dark matter is proven by its effects, but what it is made of has not been identified. One more fact sets the scale of all this. Dark matter dominates. There is roughly 5 times more dark matter than all the visible matter in the universe combined. Every star, every planet, every glowing cloud of gas is the minority. This matters because it flips the usual picture of a universe full of stars with some empty space around them. The stuff we can see is the small part. On a big construction bid, the material you can see on the invoice is often a fraction of the real total. Once labor and overhead get counted, price only what is visible and you lose money on the job. Most of the universe's mass is the kind we cannot see. Let me show you how these pieces come together on one real galaxy, the way an astronomer actually reaches the conclusion. First, they measure how fast the stars at the outer edge are orbiting, and they use that speed to work out how much mass must be pulling on them. That is gravity and orbital motion doing the weighing. Second, They add up every source of light in that galaxy, all the stars and gas and dust, to get the total visible mass. That is the limit of what the telescope can see. Third, they compare the two numbers, and the orbital speeds demand far more mass than the light accounts for, which means mass is missing. Fourth, they confirm it a different way by measuring how that galaxy bends the light of objects behind it, and the bending points to the same large amount of extra mass. Then they check whether faint stars, coal gas, or black holes could quietly fill the gap, and after counting all of them, the shortfall survives. 5 separate ideas applied to one galaxy land on a single conclusion. The extra mass is real, it is invisible, and it is detectable only through its gravity. Here's what people most often get wrong. The most common mistake is mixing up dark matter and dark energy. Both have the word dark and both sound mysterious, so people fold them into one thing. The fix is to remember the direction of the force. Dark matter pulls things together. Dark energy pushes the universe apart. Opposite jobs, opposite words. Do not let the shared label collapse them into one. The next mistake is thinking dark matter is antimatter. The names sound like a matched set, so people assume they are related. The fix is to remember that antimatter is detectable and violently destroys normal matter when they touch, while dark matter does neither and barely interacts with anything. They are not two versions of the same idea. Another mistake is assuming dark means black holes, or literally black objects floating in space. The word dark makes people picture something you would see as a dark shape. The fix is to know that dark here means it does not interact with light at all, not that it looks black. You would not see it as a shadow. You would not see it at all. People also assume it is just ordinary matter we have not spotted yet. It feels like a simple detection problem waiting on a better telescope. The fix is knowing that the faint stars, the cold gas, and the black holes were already counted, and the gap outlives all of them. This is not hidden, ordinary stuff. It is something else. The last mistake is believing scientists already know what dark matter is. Confident headlines make it sound settled. The fix is to separate the two questions. That dark matter exists is very well supported. What it is made of is genuinely unknown, and anyone who tells you otherwise is getting ahead of the evidence. Understanding this pays off in a few concrete ways. You can read science headlines without getting fooled because articles constantly swap dark matter and dark energy, and knowing the difference means a sloppy headline cannot rewrite what you understand. You can tell honest science from hand-waving because you now know dark matter is proven by its effect but unknown in its substance, which lets you spot a real open question instead of accepting an oversold claim. You can follow any discussion about the structure and future of the universe without getting lost because you understand that most of its mass is unseen. And you can recognize the same reasoning in your own work because inferring something hidden from its measurable effects is exactly how diagnostics and audits and engineering checks operate. Spotting that pattern makes you better at trusting solid, indirect evidence and sharper about noticing when someone skips the confirmation step. So here is what you can now do. You can explain why a galaxy needs extra unseen mass to keep from tearing itself apart as it spins. You can keep dark matter, dark energy, and antimatter straight and say what each one actually does instead of blurring them together. You can describe the two separate lines of evidence, the orbital speeds and the bending of light that independently point to the same missing mass. And you can state plainly what is settled and what is not. It is real, it works through gravity, and it makes up most of the mass in the universe. What it is built from is still an open question. That is the understanding you should have been handed the first time anyone mentioned dark matter to you. Now, you have it.